Hi everyone. I'm sorry I can't be at work today. I'm still home with the flu, but I don't want us to get too far behind, so we're going to go ahead and start our notes 3B today on trig graph translations. So you'll remember from previous math classes that translation means a slide. We're keeping the shape of the graph the same, but we're picking up the entire function and moving it somewhere else in the coordinate plane. So again, the overall shape of our graph isn't going to change. A sine function and a cosine function, which looks like waves, they're going to be the same wave with the same period and the same amplitude, just sitting somewhere else in the coordinate plane. New midline, new y-intercept. The rules that we learned about translations way back in Math 1 and Math 2 still apply to trig functions. So I know that vertical translations happen when I add or subtract a constant to the end of the function outside of the function itself, and basically adding a number to my answer. And that's going to move our midline up or down. It moves the center of the shape up or down. If the constant is positive, it's going to shift the midline up. If it's negative, it's going to shift the midline down. We know that horizontal translations show up inside the function next to the independent variable x. Those move the graph left or right, meaning it's the y-intercept that's going to change. We also know that when we have a constant added or subtracted to the independent variable inside the function itself, that when we pull that constant out, the sign changes. The signs work backwards what they think they should be. So in the equation, if we're subtracting something from x, we're moving to the right. If we're adding something to x, we're moving to the left. We're going to go ahead and do a whole bunch of examples to practice this. One thing you'll note about all of the examples is that there's no constant in front of the independent variable x, meaning all of these graphs have the same period as their parent function. These horizontal translations will look a little bit different if there's a period change here. The shift won't just be this, it has to take into account the new period here. And we're going to hold off on talking about those special cases until after our midterm next week. All right, so we're going to go ahead and start with graphing sine of x minus pi over 2 plus 2. And the very first thing I'm going to do is in pink, I'm going to graph its parent function, sine x. So I know sine starts at 0, and then it goes to 0.7 something, and then it goes to 1, and then 0.7 something, and then back to 0, and then it does the same pattern in the negative direction. And so we see our nice pretty sine curve here. Now looking at the equation, I see two changes. I see a horizontal translation here, and I see a vertical translation here. So I'm going to do these in two different colors. So let's do orange and blue. So this, I know, is going to shift my graph pi over 2 to the right. Because remember, if I scroll up, I know that negative means to the right. And then this constant here outside of the side function is a vertical translation, and it's positive, so this is 2 up. So I'm going to track the midline and y-intercept. So my y-intercept, we'll start in orange, is going to go pi over 2 forward. So here is going to shift here. So here's that new point. And then the plus 2 is going to take that and shift it up here. So my new y-intercept is at pi over 2, comma 2. My new midline is here. I'm going to make that dotted. Just give me a second. And I know the pattern from the y-intercept. Y-intercept, and then it goes up to 0.7 something, up to 1, down to 0.7 something, back down to 0. So 0, and then 0.7 something above the midline, 1 above the midline, 0.7 above the midline, back at the midline. And then it repeats, but below the midline. So 0.7, 1, and then coming back this direction, we get 0.7 beneath the midline, 1 beneath the midline, 0.7 beneath the midline, 0, 0.7 above the midline, 1. And you'll notice it looks like the same shape, but I can see the peak has gone forward pi over 2, up 2. The y-intercept has gone forward pi over 2, up 2. This point has gone forward pi over 2, up 2. The shape is the same, we've simply picked it up and slid it. All right, we're going to do the next one together, and then I'm going to have you try the backside on your own using technology. So the next one says cosine of x plus pi minus 1. So I'm going to do the same pattern. I'm going to use pink, and I'm going to graph the parent function cos x, and then I'm going to use orange for my horizontal translation, and blue for my vertical. So we'll start with cosine. Cosine starts at a peak, so it starts at 1 and then comes down. So 0.7, 0, negative 0.7, negative 1, and we get the same on the other side. Cosine is symmetric about the y-axis. 0.7, 0, negative 0.7, negative 1. So that's our parent function. And then looking at the translations I see present in the equation, I see a plus pi, and I know plus inside technically means to the left. So I'm going to go pi to the left. And I know that this represents a vertical translation, and it's negative, so it's 1 down. And I'm going to do what I did last time. I'm going to track the y-intercept and then re-sketch my midline and track the pattern. So first we want to go pi to the left. So I'm taking my y-intercept and I'm going all the way out to negative pi. So I'm now sitting here, and then it says 1 down. So my y-intercept is now here. Notice that my original midline was here, and it now should be one lower, so my new midline is going to be down here. So let's get our blue pen and sketch our new midline. So -1. I know my new y-intercept or my old y-intercept is now sitting here at -pi, 0. And then I'm doing the pattern that I saw up here. This dot here is now a peak. So I'm coming down, whoops, not quite that low. Try again. It's a 0.7, 0, 0.7, -1, and then we go back up, 0.7, 0, 0.7, 1. Again, I can see the same shape, but it's been shifted down and to the left. Whereas before I had a peak at x equals 0, now I have a trough at x equals 0, and the midline is down, so it's much lower. It's at -2 instead of where it would have been before, -1. Reminders that if you need help, the best way to do this on your TI-84 is first check that you're in the radian setting, and then plot two functions here. So for example, for let's scroll down and do number 3 on our calculator. I want to do 1/2 tan x minus 2. The very first thing I'm going to do is plot tan of x. That's my parent graph. And then I'm going to do 1/2 tan of x, and make sure I close parentheses just like it is on the paper, minus 2. Here I can see two things happening that are a little bit different than our last example, in that I know numbers in front are a change in amplitude, and I know changes outside and in the back shift the midline. So this is going to go down 2. But let's graph that and check. Why does that look weird? Let's go zoom 6. There we go. So remember, if I go back to y equals, blue is the parent, red is the new. So when I go back to my graph, blue, I can see tangents passing through the origin, which is where its y-intercept should sit. And then if I look at the red, which is the transform, the intercept is now down at -2, which is where I expect it to be. You'll also notice that it's a steep S shape for the blue, and it's a shallower S shape for the red, because it's a smaller amplitude. I'm squishing that curve down. All right, you've got the rest of class. I'd like you to try 3, 4, and 5 using technology to help you. I'll post the answer keys on Canvas later this weekend. If you have questions, let me know. Reminders that you should use the rest of class time to finish the week 5 Delta Math or work on the midterm 1 review. On Tuesday, we'll correct the practice test. We'll answer questions about the midterm, and midterm 1 is on Wednesday or Thursday, depending on when you have your block period. Don't forget the study guide is available in Canvas. And again, if you have any questions, please send me an email. Otherwise, I will see you on Tuesday.